Well, hi, and thanks for joining me here today in my shop. I'm going to be starting on this Northern Electric radio, which I've had for some time. This was given to me by someone whose other radio I fixed up, and they gave me this one. I haven't done anything with it for a couple of main reasons. The obvious one is this big dent right in the grill here kind of wrecks the radio, wrecks the look of it. The other thing is, it's not too exciting of a radio, is it? It's just an AM radio. There's nothing too fancy about it. It has some serious cabinet problem here with a big crack running right through here. Whoops, can't even see it, can you? It's a big crack with a hole down here. And when you look in the back, it's a bit of a horror story. It's all dark. Looks like somebody smoked cigarettes and blew the smoke in here the whole time. That's what it looks like. So lots of reasons to not try fixing this one. But none of them are terminal reasons by any means. There's nothing about this radio that so this plug's not on there properly, but the cord is as stiff as can be. Gee, should I just plug this guy in and see what happens? kind of like doing that. Just look the cord over very carefully. So this radio isn't as old as many of the other ones that I do. Now, oddly enough, it has a knot here on the outside. Now, who would put a knot on the outside here? The idea is to put the knot on the inside so you can't pull the cord too far. So this, suggests to me this and the way this plug has been done, and the style of the plug. This is a hardware store plug. You go buy one of those in the hardware store back in the whenever. This cord's not original. It's got its tubes in there as far as I can see. We're all in there. 1, 2, 3, 4, 5, the magic number 5. And I don't see any transformer in there at all. So I think we can call this a 5-tube radio. If any one of these are 12s, well, we'll eventually get the radio out of there. We'll see for sure. Let me turn the dial here on it. Huh, okay, can anybody see that? Yes, you can see that. You don't know what you're seeing yet, so let me point it out. Can you see that right there? You see a bit of it down here. Okay, so that's where the dial string is supposed to be, and it's a tie wrap. There's a tie wrap in there. Yeah, and that's how effective it is right there. I'm turning away and that's it. Well, my hat's off. I've never imagined anybody would try that. I mean, why wouldn't you just put a piece of string there? Why put a tie wrap there? I see there's a cut wire here. This is an AM radio, so I'm not sure what that wire is doing there. You wouldn't normally connect another antenna to a radio like this. The loop antenna is a critical tuned part of the radio. This doesn't seem right. Here, there's a wire coming from this terminal. It's just hanging out here, and it's got the two light wires soldered to. I don't know what's going on with this. Something's going on with that. What else can we spot from here? Not too much else. The output transformer's up here on the back of the speaker, and the speaker is a permanent magnet type. I say we should just plug them in. All those in favor of plugging in this radio and seeing what happens, raise your hand. Now I could do that safely here in my shop. I can do it safely. I'm not saying I will. So we're going to look once again. What I'm looking for when I look down in here are loose strands of wire. That's spider web there. Loose strands hanging out here, hanging out over the edge where I can get it with my finger or something of that sort. See, these are pretty close. There's one here. That screw doesn't even look tight on there. That's another thing I should check. Oh my, this screw is loose on there. Why don't we do this the right way now? Since I'm fiddling with it. good chance I won't change this cord, even though it's stiff. So the way this is done, this is the way most people would tend to do it without knowing the trick here. The way this is done can easily lead to a short circuit or an electrocution. Come on out of there. Wow, it's really holding on. Holy smokes. You got it tight under there? What's he done? Nothing. Nothing special. Really, look at, so this is way too much bared off copper here. Now that in itself is a problem. Because he solved that problem by wrapping it repeatedly under the screw head. So if you wrap the wires under the screw head so they cross, especially a single conductor. Let's say this is the top of your screw head. So you take the wire and you wrap it underneath. First of all, I've done it the wrong way. It should be wrapped this way. Now, my fingers don't work well that way, okay? You should wrap it this way. You tighten the screw, you pull the wire under. Secondly, you should not wrap the wire all the way around. Okay, so this is now the wire. So you wrap it all the way around, okay? This is just terrible. Okay, you wrap the wire all the way around, it crosses itself. So now you got a point of crossing. Because you've wrapped the wire right around, you screw it down, the screw only contacts the high point where the two wires are crossing, and then you screw it tight enough, you cut the wire. There you are. Don't do that. So look at that. See, that's just way too much wire. I didn't plug this in, did I? No. So we're going to fix this guy right up here. First of all, goodbye to you. This insulation is already a little stiff here. But it's not so bad it's going to crack or something like that. Okay, so we're already through. Like, I've already got the plug on the wire. Don't worry about making that mistake. Trim this back. Roughly enough to go under the screw head all the way around, but not overlap, without any excess wire not making it under the screw head. So you got to kind of figure that out. These wires I can see are not in the best of shape. Even though they're up under the insulation, the moisture in that can travel up, the water itself can travel up to these conductors. Like if you drop this in water, the water will get in among the conductors and just be drawn way up into the cable. Not that many people are dropping these things into water. Okay, now for the secret maneuver on this. Okay, separate these enough. Instead of going straight to the screw, you get to the screw by coming around the back. See, and that brings you right into the screw head. The right point where you're not going to get insulation under the screw head, if I've done this right. Also, I have not put solder on the wires. You know, you could do that if you wanted. The advantage of that is no loose strands, because this is the big danger here. So get this done and you've got loose strands hanging out. So you clamp this down firmly. Good. You can imagine the individual strands kind of splayed out as I squeeze them down in there. There we go. So this kind of provides strain relief on the wire too, on the let's see if we can get it under there. So you might think it's a small deal, but this is one of the few places where you can grab both sides of the line with one hand. You can touch both these prongs simultaneously, and you've probably done it somewhere in your life. Maybe as a kid when you tended to not be so careful. yank something, some plug out of the wall and accidentally touch both prongs as you do it. Yeehaw! And according to Dr. Pozak, the investigator at the coroner's office in Ontario, told me his focus was death by electrocution. He investigated all the electrocution deaths in the province. And I'm going to why I was talking to him. He told me anytime you get a shock at 120 volts and you live, count yourself lucky. Generally, yes, you are going to live. It's a little hard to get killed at 120 volts. People do it all the time, though. But his comment to me was, every time you get one of those shocks at 120 volts and you live, you're lucky. Well, I don't think I want to count on luck to stay alive, so. Anyway, okay, so we have this on here now. You can kind of see how the wires run. Okay. What we're missing is the top cap that should go on here. The thing about doing it that way is if you yank on the cord, it's kind of strain relief. You're not really yanking right on the connections. Plus the other way, with all that bare copper the guy had, over time, yanking on the cord, the wires back out under the screws, they come out a little bit, they start going down the tunnel here, and all that bare copper, boom, it's going to short out. They get short right between the prongs again. So that's why I dwelled on this. Silly little guy here. Now we are going to try and set this thing on fire. Let's see. Switch off, but we have no idea if the switch works. Tuning is a little bit restricted there, but we know why. Now, I'm going to plug it in, because again, this might be the first, you might be a new viewer of my videos, so I will explain a little more. So I'm going to plug it into this outlet. This outlet is not plugged straight in the wall, it's plugged into a transformer, and the transformer is plugged in the wall. So what that means is my power supply here, although it's 120 volts, is isolated from the power system. And I'm plugging in a two-prong plug here. Two-pronger, not a three-pronger. Wouldn't matter anyway. The third prong down here goes nowhere because this is an isolated system, and also because, well, I'm using a two-prong extension cord, so the ground prong's actually just sitting out here. Look, I have a backup fuse back here, a small fuse, a couple amp fuse, just in case. And this guy himself is a machine that'll tell me the voltage that's on the plug here. I also have some other voltmeters like this one here will also tell me what the voltage is at the plug. So now when I'm going to turn on something like this, I don't want, Niagara Falls power rushing into my house here in a short circuit. So to limit it, I put a light bulb in series with the radio right in the power line. And those light bulbs are mounted up here. And I can engage them just by throwing this switch downwards. Now there's no power here yet because I have a master switch. So I throw this down. These lights are in series with this radio. And that's why I can turn this radio on. If this radio's got a dead short in it or something really badly wrong, something that might tend to blow a fuse or start a fire, the light bulbs are going to come on full blast. Nothing's going to catch fire here. Dim bulb system. I really like it. It seems like a clunky thing, but I find it really effective. So my expectation now, this can go from being a safety device to a test system. So when you first turn on power to a radio like this, the tube filaments are cold. And as we saw in some of my tube experiments over here, when you're expecting maybe half an amp in the tube, the initial inrush could be 2 amps. Now you put 1, 2, 3, 4 tubes. Oh my gosh, well that's 6, 8 amps of inrush current. So it's going to attempt to draw a lot of current when I first turn it on. When it does that, these lights are going to get really bright. But shortly afterwards, the filaments start to heat up. And as they heat up, their resistance goes up, and the draw, this heavy initial draw, begins to go down. This only takes a couple seconds. It happens pretty quick. So what we should see in these lights, when I turn on the radio, is the light should come up quite bright, and then zoom down, and then sit for a bit, and then slowly start coming up again. So why would they come up again? So given enough time, the heater in the rectifier tube in here will heat up, and the rectifier tube and its power supply circuitry will start producing high voltage that will then be passed into the radio to the other tubes, who will then start conducting. So yeah, the first thing is the heaters come up. It's actually more like this. The heater current, like this, and then it stays there. And new current starts flowing once the rectifier and the high voltage comes on. A new current that's actually flowing through the tubes themselves, and it rises up a bit. When the current rises up a bit, the bulb gets brighter again. Okay, so we got that. Let's just review one more time. I hit the switch. The lights go right down, and then slowly come up. And as they come up, we should start hearing stuff out of the speaker. Okay, so that's how you use those light bulbs, like a test instrument. Ready? I'm ready. Okay, so we have the lights are engaged, the switch is off. So we'll apply power, nothing should happen. Okay, so conceivably, there's 120 volts in the back of this radio, but the switch is off right now. So it's good to test these switches first off. So I'll just show you a couple other things in case you're the first time watching. So here, that's the actual voltage reaching the plug. And because there's no current flowing, it's the same voltage in the radio. 124 volts. That's typical in my house. A little on the high end. Maybe I should complain. Get that knocked down to 120. Save some money on my hydro bill. So now we're ready to turn on the radio. Which I'll use this switch to do it. So you see my hand turn it on, you watch these lights, remember, bright, down, and then slowly up a little bit. Then sound comes out. Here we go. Right down to nothing. May not see them come back. I'll put the volume up a bit. So that was normal. Now, because the voltage is restricted a bit, 120, it's not much of a restriction, is it? It takes a while for it to warm up. Here it comes. And she's a hummer. Okay, that's all we need to do. So what this has proven is the power supply filter for the high voltage, the capacitors in it are bad, and that's where that hum is coming from. Sounded to me like it was working. Sounded to me like it was working. Can you say that one more time? So I'm feeling great now. So I think the chance of restoring this radio to full and decent operation is almost 100% at this point. So I am happy to go forward with it. So what's next? Next is we remove it from the cabinet, give it a more thorough inspection, look up underneath, see what kind of situation is occurring there, clean it up a little bit, get some dust off some critical parts, make some more observations, and then plan out a repair approach, which you can almost guess. It's going to boil down to removing or replacing the capacitors in here. So this is a 5-tube radio. It has a chassis voltage danger to it. So I'm just going to show you this too. So I've taken the knobs off, and see there's nothing sticking out here. Now a lot of radios, you know, the knobs stick out. When you pull the knob off, the shaft sticks out. It doesn't stick out on this radio. That's a warning. That's not by accident. These have a long neck on them to reach inside the radio. So what they're thinking is, people who don't know anything about the dangers of these radios, just an ordinary everyday consumer, could get themselves into trouble with a radio like this if they touch the chassis anywhere and something grounded in their house, water pipe or something like that. So to reduce the chance, things like metal sticking out here are eliminated from the design. So if you pull this off, you can't energize yourself. If you stick your finger in here, well, okay, too bad for you. Now, there's no back on this radio. Luckily, the antenna is mounted over here. A radio like this often has the antenna mounted on the back, and often the back is gone, the antenna's gone. Radio's never going to work well. You really need the original antenna with these radios. And I'm looking to see how the speaker is handled. It looks like the speaker is mounted right on the chassis. So when I pull this radio out, everything is coming out. Excellent. Oh yeah, I was going to say, if the back is on the radio, your hand cannot touch any of these metal parts. In this radio, the antenna is built right in, so there isn't even an antenna wire hanging out for you to grab onto and get a surprise. You know what else? I should clean this up. I'm going to get this out of the. I'm going to get it out and clean it up, and then we'll take a look at it. So I turn the radio over to take the screws out, and surprise! There's some information here. Flip it over this way. Northern Electric Company Limited, Belleville, Ontario. Radio receiver model 5200. There's the model number. Tube locations. Licensed by Canadian Radio Patents Limited, only for non-commercial reception of radio telephone broadcasting. So you can't use this radio to receive your broadcast and then rebroadcast it, I guess, what they're saying. Guarantee, made in Canada. And a big warning down here. So it's a warning about the license. What's that huge warning there? Let me just look at it here. Any person installing or operating this receiver set without first having obtained a license from the Ministry of Transportation of Canada is liable on summary conviction to a fine not exceeding $25. Yow! Ouch! $25. And the said receiving set may be forfeited to His Majesty by order of the minister for the something disposition as the minister may direct. Straight from the Canada Gazette. Canada Gazette is an official government publication of government rules, regulations, and findings and things like that. Oh, I don't have a license. So that's interesting. Now it says His Majesty. So this is before the Queen Elizabeth, who is the Queen of Canada, by the way, before she was in her seat. So wait, I got another screw here. Yeah, got all excited because I'm worried the Queen of England's going to drop in here any minute and take my radio from me. You do not have a license. So what was it? Why have a license? I'll tell you why they had a license. The license provided your address. So they had an address for where a radio was working. So then they could run around the neighborhood. My hard drive got jammed there. So they're running around the neighborhood. It's the last thing I said that got caught on video. Could run around the neighborhood with their directional antennas and come up to your house and pick up your local oscillator and look on the list and go, oh, the person in this house has a license to operate a radio receiver. And on they would go. Now maybe they get a little out of town, out by a farmhouse, away from everybody, pull up, outside the farmhouse, pick up a local oscillator from a radio. Check the list. This guy's not got a license. He's not got a license, but he's operating a radio. He's a spy. He's a spy listening to shortwave, to things like numbers stations, which, if you're a shortwave guy, you know what I'm talking about. Number stations are spy communications techniques still used, wide open in public on shortwave. I hear it somewhat regularly. I picked one up just a couple weeks ago. I was stunned. So that's why there was the need for a license for these, so you could find the spies among us. And so that also dates this, because this is talking about His Majesty, not Her Majesty. And I couldn't tell you, but this is older than I thought. So when did Queen Elizabeth become the Queen? I don't know. Do a little research and try to get a date on this. Well, if I do too much research, I got a sheet on it right here. Maybe it says right here. Quick look. Let's do a quick look. Baby Champ? Is that what this is called? Baby Champ. Well, there's no date on here that I can spot quickly. Okay. Let's look underneath. See what we got here. Tip it up this way. Well, we got a pretty original radio there. That's for sure. So just a quick look to see if anybody's done anything. So here's the power cord. See how nice it looks inside here? So I think this is the correct power cord. It is knotted inside. Why they knotted it outside, I don't know. It's kind of a waste of a knot. Actually, when you knot these things, you put a lot of strain or stress into the plastic here, and this is where it's going to crack early because it's chemically energized by the mechanical strain that's put into it. So don't do that. And back in here, well, it's protected here inside a metal can basically. It's not going to degrade nearly as fast, so you get away with it here for decades and decades, but maybe not out here. And just look at the difference in the cord. See, this is what happens. You live your life indoors, you look like this. If you're a farmer, you look like that. Accountant, farmer. Now, it's got molded capacitors in it, which are known bad actors. And all these wax ones here are also known bad actors. It's not loaded with dust and dirt down here. That's great. Look. Oh, it has a phono output. Hey, this radio just went up a notch. Phono input. Phono input. On-off switch stuck on the back here, just like any. So now look for any burned open resistors. No, look for a high wattage resistor. There's one here. Looks okay. That's probably in the power supply. This is probably the filter capacitor up above. It's a major connecting point for this radio. A lot of wires just coming right in on this point here. Just looking quietly. Otherwise, this looks pretty good actually. Looks pretty good underneath. So, lots of capacitors. How bad are those capacitors? We can't really tell until I test them, as I have learned many times. That you can make an observation on the condition of them, and you know, if they look really bad, they probably are really bad, but not necessarily. So this is a filthy, dirty radio. Like it's really dirty. So I have heard of people hosing these things down, just blasting them with water. I've heard of people dumping these things into tanks of WD-40 and stuff like that. I'm not doing anything like that. I will just try to dust this off as good as possible. There's an awful lot of dirt down in the capacitor here. But again, I'm just going to try to vacuum all that out. I think I'm going to pop all the tubes out. They're filthy. I'm going to clean them carefully. I'll be able to double check that they're the right tube, because once in a while I get a radio like this and somebody has moved the tubes around. They're in the wrong spot. Or it actually has the wrong tube in it. So I think the odd person out there thinks, hey, these tubes look pretty similar. Let's try this one. Probably not a good way of doing it. 12 SA7. Okay, so the 12 is not a surprise. This is a metal-based tube here. It's a little more rare. This is probably the SK or SQ rather. 12 SQ7. I can't even read the number. It says Northern Electric down here. So I got to clean it to even read the number on it. And you notice I'm prying them from the bottom. These metal tubes are really rugged, so you don't have to worry too much about them. The glass of Addison. 12, there's the SQ. 12 SQ7. See, the glass tube, if you like, has come loose from the base here. So if you start tugging on this and twisting it, goodbye to this tube. And this guy is a mystery tube also. So I don't know if that's cigarette smoke. I mean, this looks like cigarette smoke here. Pop this guy out. Also, this is probably the output tube. 35Z5. This is the rectifier tube. This is probably the output tube. Well, these two tubes run a lot hotter than the rest, or they should. And the dirt on them, like you really want these to be clean to throw off as much heat as possible. You don't want them to be basically insulated by a layer of dirt like this tube is. There we are. Wasn't that fun? Just taking the tubes out. Lots of fun. Very interesting. So I noticed something kind of unusual. This is unusual. There's a insulating material here below this can. Not so on this one. Never seen that before. You can see the metal hold down nuts are going through. If this is isolated from the chassis, then there's got to be isolation right through the hole and everything. Let's look underneath and see what's going on there. Never seen that before. Hard to see, maybe in the camera. Well, you can kind of see it, but down in here is a screw, and they are not touching the chassis. Oddly enough, I see rivets. I see rivets right in here. What is being riveted? Where's the other can? The other can's over here. Well, that's pretty interesting. So the other can, is screwed down. That's one screw there, and the other screw is under this. Sating screws, eh? Clever engineers. This one is screwed down, but there's isolation pieces underneath. What are the rivets for? It has to be riveting something inside. What? What do you mean? I mean, like this can is completely floating. Now that's weird. That's not like normally you want to ground these things. Basically, by grounding them, you create a shield through which electromagnetic radiation cannot get in or out, because it has to pass through a ground potentialed piece of metal to do it, and it can't. So why would they leave this floating? I don't know. So there's the big filter capacitor too. This is the guy that's causing the humming, so he'll get replaced, but not replaced entirely. I'll leave him in, and that's a 4-parter. 40, 40, 40, and 20 microfarads. That's 4 capacitors in one there. It's going to get a little crowded underneath as I try to pack them in. Yeah, I don't think I can make any more observations, so I'm trying to decide whether I should hose this. You know, if I hose it, I got to leave it for like a week to dry out. Although, actually, in my house, it would dry out in 15 minutes, come to think of it. Should I do that? No, I've never done it. I've never hosed a radio down. What could go wrong? Hey, water inside these cans, water into paper and other absorbent materials. Water on the speaker. That would not be good. Probably water under there wouldn't really matter much, as long as it's dried out, and the parts it might affect I'm going to replace anyway. And I can kind of hose it nicely down like this. I'm going to splash water onto the back of the speaker. Potentially warp the speaker paper a little bit, and then, you know, it's all about the speaker, isn't it? It's all about the speaker, so mess up the speaker, radio shot. A dusting and a vacuuming is what I have to do. As much as I'd love to just let that thing go with a garden hose on it, but I'm not going to do that. So I'm busily, I vacuumed this all off. It came out pretty good, I think. And I'm cleaning these tubes, and these are tough to clean. This dirt is really adherent on here. and it's really built up on the top. That tells me this radio was on a lot and was somewhere, you know, in a shop or a garage or somewhere where somebody smoked a lot. Like this is thick. With a coating here, look, I can practically chip it off. Huh. So these are among the worst I've ever seen. So I'm trying my best not to wipe off the numbers that are on them. And of course these aren't all Northern Electric, Northern Electric. These three are all Northern Electric. Are these all original? Tubes, Addison, no. Westinghouse, so it had a couple of tube replacements. Oddly enough, not the output or the rectifier tube. What a mess. So, okay, this is a tough job. Tough job. Cleaning the tubes all day. So now that I'm cleaning these tubes and discovering a lot of them don't have a label on them. These are monsters to clean again. I made a classic mistake. I pulled all these tubes out. I never noted where they were plugged in. I expect them to have numbers on them, and I can sort it out from the schematic in that if need be. It's not something I would normally worry about. But here I have a bunch of unlabeled tubes in my hand. I don't know where I got them from. Wow, this is just like, this is caked on. This is chipping off the top of these tubes. I'm using a fairly powerful soap here. Oh my gosh, that's unbelievable. Where was this radio? You know, when you look at like the back of the speaker, you look at these cans, I think it's in a bakery. Where would it have been that I would pick up this kind of stuff? Well, who knows? Could be anywhere. Could be anywhere. Wow. Yeah, it'd be interesting to know just where these radios have been, where they've spent time, how many different owners they've had. A number of people have commented to me they'd like to know what kinds of important things have come out of the speaker here. What kind of news stories have been heard through it. And, yes, if you want to get romantic, you can. So, of course, these steel tubes aren't so bad. Because they're newer, I think. That's the deal there. Okay, I don't think you want to watch me sit here and clean tubes all day, but I have to get these cleaned off. I know what they are. Where'd they go? What are they doing here? Well, these are the dirtiest tubes I've ever come across by far. Trying to scrape the stuff off these tubes. I'm using a magic eraser here to kind of scratch the stuff off. Wow. This one, the label's on the top here, 50L6. You'd have no idea there was anything on the top of this. In fact, no idea. But any of this, so they're all identified except this one, so it'll be easy to figure out which one this is. Its label is completely gone, but since the rest of them are known, no problem here. No problem. Anyway, so what next? I won't try any kind of fancy cleaning on this. I don't care about it. So this can stay the way it is. The tuning capacitor, unless somehow a problem is identified with it, there's really nothing much I can do about that. Here's another look at the tie wrap solution to the. Yeah, that's pretty dumb. That's dumb. Why not a piece of string? Why would somebody do that? Was there something there before that made him think this piece of plastic would be better? No, it has to be a piece of string. So the next step along the way here is, without a doubt, whoops, spin my guy all the way around, is to start replacing these capacitors here. Let's see, can we flip this guy upside down? It's going to sit on his antenna if we do that. Looks like we can pop that antenna off its bracket pretty easily, but no. So I got to figure a way of propping this guy up so I can work on him. Change all those parts. That's where we're at. Okay, I think I'm ready to start on the capacitors. I think the first thing I want to do is deal with the hum in the radio and see if we can't clean that out. Now, I already mentioned that the main filter capacitor is here, and I mentioned that, wow, there's a lot of wires coming to it. It's almost like a center of action here in this radio. That's a big problem. You want to get off the terminals to the existing capacitor. I don't think it's wise for me to, I mean, it's easy, but I don't think it's wise to parallel in a bunch of new ones with that old one sitting there. You know, I'm going to have to think about this. Because if you decide to isolate the old filter capacitor, then there's a huge challenge with where you put all the wires in the new capacitors. Because this radio is depending on a whole bunch of terminals in here. 1, 2, 3, 4, 5 or 6 terminal connection points here. The wires are all cut to fit here. Everything is here. And so if I decide, you know, this isn't going to be good, I got to do another set of 4 capacitors in here. That's quite a headache. Paralleling them in is a fairly easy thing to do. So I really got to stop now and think hard. Why wouldn't I parallel in more capacitor? And I think the only reason is because the old capacitor is a problem. Well, what kind of problem? It's leaky. Is the capacitor leaky in here? Maybe I can test it and determine that first. Try to determine the condition of the filter capacitor. Now we know it's not filtering because of the radio's humming. We don't even know how, if it's just one part of this that's gone bad. Probably if one part's gone bad, they're all questionable. So there's 4 parts in here. One part is going to be the bypass on the cathode resistor of the output tube, almost certainly. The other 3, all part of the filter. I do have the schematic here. Why not look upon it? So there's a rectifier. There's 1, 2. There's 3 of them there. Oh, this one is. Oh, I see what they've done. So this is a 5-tube radio with a hot chassis. The potential for a hot chassis. I should look into that too. We'll look into that next and see if this has really got a hot chassis or not, or how they've dealt with it. What I see here is a large capacitor. It's electrolytic because of the symbol they're using, and it's between the outside. Yeah, if you look at the phono plug here, you can see it's heavily insulated from the chassis. There's no connection between anything on this plug and the chassis, I think. Now you know what? That's really interesting because down here is a rivet. Looks like there's 4 rivets. There's only 2 appearing on the other side that you can see. That's these 2. Okay, these other rivets are just riveting components together in this sandwiched up deal. Yeah, I can actually see the rivet. Yeah. So is this... I've got to take back what I was going to say. I thought this capacitor was connecting to the chassis through a rivet here, but it's not. It's connected to a rivet that basically picks up the ground part of the phono plug here. Okay, never mind. So I'm just mixing a couple things together. You know, how is the chassis dealt with in this radio? What's going on with this phono plug? But that's the capacitor. That's not the big capacitor. That's a small capacitor. I see a great big one here. See something with a number and all that. So I'm not going to study this enough right now to sort that out. But yeah, other question. How is the chassis energized through a capacitor? That's kind of essentially the question. Maybe we can spot one here. So there's a capacitor with a chassis symbol on it. There's a chassis symbol there. So I'm looking now. Some of these schematics you'll see connections to the chassis all over the place, especially with the heaters. How are they showing the heaters in here? They're showing them down here. Of course, these are in series. So you're not going to find a bunch of chassis connections on series. There's another big capacitor there. That's 5 of them. 5. How do you get 5? How do you get? Where's the 5th one? So, I mean, I can't rely on these symbols. Oh, I just realized they've used the same symbol everywhere for a capacitor. A straight plate and then a curved one. So sometimes, you know, that identifies the electrolytic capacitors, but they haven't done that here. Okay, I know you can't see this very well, so I'm not going to dwell on this piece of paper here too much more. Let's follow the plug. So incoming plug, there's a switch, and it's very hard to see. There's a connection to this, what would be the ground wire, I believe. Connection right there, right to the prong. Now, is this a ground wire? Is this wire? How does this wire get connected to the chassis? That's my question. The chassis is going to be connected somehow. They won't leave it floating. So we can come all over here. There's a chassis connection here. Wow, I'm going to have to study this more carefully, I think, to sort it out. There's a few chassis connections, but not many. I can't quite spot, like this one's made through a capacitor, this one's made, it's made in this circuit, which is, it's tied in. Okay, I don't know what's going on. We'll study that more carefully later. For now, it's a question of observing what's going on with these two. So here come the wires. This one goes to the back of the switch. We come out of the other side of the switch. We have a bare wire here. The bare wires often indicate that they're at chassis potential. I didn't vacuum back here. So another bare wire coming off and tying to the lead to this capacitor. And it's on to the volume control. So this is the bottom of the volume control. This is probably the incoming audio fed into, I better call it the top. So this would be the bottom. The bottom of the volume control comes through a, what's this, 22 million ohm resistor. Okay. This terminal strip has no grounded terminals. All the terminals are floating. One of them's not used. Ooh, I need terminals. It's right near the capacitor. So I have a free terminal here I can use. That's good. That's helpful. Here's another one. Okay, so this terminal is mounted onto the insulated post. Well, that's really interesting. Okay, so that insulated can on the top, the IF can, is connected to, let's be sure now, through this bare wire to this terminal of the tube. The can is connected to this terminal of this tube. There's a black wire that runs from there and disappears up in here. Looks like it just goes to another tube. Huh. Okay, so the process you're seeing me going through here, I'm just randomly making observations and becoming more familiar with the radio. Here's another high wattage resistor I hadn't really picked off, and another one down here too. This is a long one. You can't see it under the capacitor. It's a long resistor, indicating it's a higher wattage one. Some pretty clumsy places to work up in here. This is almost certainly the oscillator coil here. It's contained under the chassis. It's got the trimmer mounted right on it. Can't trim this unless this chassis is right out. But this radio, when the chassis is out, you still have the dial to look at. So that should be okay. And the capacitor, the tuning capacitor, is up on these rubber mounts. And you can see the connection point here. Maybe you can't see it in the camera, it's right here, to one leg of the capacitor supports. So the capacitor frame is connected back here to this point, and there it is. So again, it's bare wire, which is a hint. I mean, it's cheaper, right? Bare wire is cheaper, so they use the bare wire wherever they can. And bare wire runs from that terminal to this terminal here, which is actually a terminal that is essentially riveted to the chassis through the frame of this socket, the bracket of the socket. So there it is. So there's the connection point right there. Where? What am I seeing here? It's kind of weird. You know, I've never fully understood isolation of the capacitor frame. Here it is isolated, and here it is grounded solidly to the chassis. You know, unless they want the capacitor to be a little bit wobbly. They think there's some advantage to that, so they put on rubber grommets to give it some suspension. I don't know why. So again, I don't understand what the whole arrangement is. I'll say one thing though, I dwell on this because I've gotten one heck of a shock off a radio like this when I touched the frame of the capacitor. This is years ago. I got a full-blown 120 volt shock. That's right, Dr. Pozak. 120 shock. So that's why I don't care about the little 50 volt through a capacitor tickle shocks. They don't scare me too much. But 120 volts, I'm not going to forget what Dr. Pozak told me. And I have been lucky. How many more times can I be lucky? So, I'm sort of babbling at this point. I think I got to get on with some kind of work here. I've got to fully plan out how I'm going to deal with this capacitor. Let's check this capaciter. Can we check that capacitor? Can we check it while it's in place? Okay, that's a good question. Look at this lousy schematic again. Oh, it's 4 different capacitors. They're all doing, well, 3 of them are right here. They're tied back to the tube. That's an open circuit that way. Tied into the radio. It's kind of an open circuit that way. You know what I can do? I can take the terminals at the top of the capacitor, check them resistance to chassis with an ohm meter. If the resistance is really high, then I should be able to test these capacitors in place. So that's what we'll do first. First step is find my voltmeter. Find my ohm meter. It's right there. It's right there. Okay, so the question is, it's too much of a question for my poor meter. Yeah, put your feet out. Oh, that didn't help at all. Yeah, these are cool looking, but they are terribly unstable. Let's see if they'll remain standing now. So, to the chassis. Okay, let's check that one connection I claimed was on the chassis. That's a pretty good clean. Can you see that? You can kind of see it. Let me bring it down. Come down a little bit from up there. There. That's a fantastic. So I was right about this being grounded to the chassis, but isolated at this point for reasons I don't fully understand. Now we're going to check the same thing. Not the same thing. Well, I guess we are checking the same thing. So 1, 2, 3, 4 terminals. Here's one with an orange wire on it. So this could very well be the bypass. This could be the this is a brown. This is a 150 ohm resistor right here. That's probably the cathode resistor. This is probably the bypass for it. Not leaking. Okay, over here we got this big high wattage resistor here. This is probably the two. Is this? Well, we can look on the schematic. It's probably one of these two resistors here. Did you see that? Did you see that go by? Okay, one side more than 20K. Other side. You know, I'm going to put this up a little higher. Let's put it up at 2 megohms. You would expect to see the capacitors kind of picking up a charge, so the meter would react. It doesn't react on any of these. Is it really working? Yep, it's really working. So all these are testing pretty good. I mean, that's 2 megohms. It's not even showing up. Let's try 20. So this is telling me paralleling it is probably a good idea. So here now we're seeing a little bit here. So you know, it's 7 and above. 7 megohms and above. If this one's not showing anything. A little surprising in a way. I think these would show something. Okay, this is 200 megohms. Because I'm reading these to the chassis, but I'm doing that. Is this really the right way to do this? So I'm planning on hooking up my test equipment from chassis to capacitor. The capacitors are fully isolated from the chassis. I might as well hook one lead of my checker to some other radios in another room. I'll look at the schematic more closely. Let's continue with the... can we read any resistance here? Up from 5. I feel better getting something on the meter there. Up from 10. Up from 5. Up from 13. Schematic. Wow. I don't think this is going to help me unless I study it for a long time. We don't want to do that. So this bottom of these capacitors is related to the chassis because I think it has no relationship to the chassis at all. I really want to read the resistance, so I got to read. You know what I could do? I can do this again. Only instead of reading to the chassis, I'm going to read to the negative terminal of the capacitor, which makes a little more sense. The negative terminal of the capacitor's got what looks like that resistor on it. What the heck? Negative terminal, negative terminal. There's 3 negative terminals here. Oh yeah, let's try that. So to here, oh, that's a little different, isn't it? 200, 2 megohms. Let's put it at 2 megohms. Try this again. I think my first round didn't really mean much. That doesn't look very good. Okay, that's a short. This is on to the orange wired lead. Wow, short. Okay, maybe there's something different going on here. Okay, over to one of the red terminals. That's fine. Yeah, short on one of these. Reads as a short at 2 million ohms. Let's put it down to 2K. Maybe I'm reading this resistor. I can see the orange wire right here. I'm reading this resistor. 150 ohms, what it should be. 152 ohms. well, it makes it, with that resistor there, I can't be testing this terminal. The other ones should be testable. From, yeah, let's just repeat this one last time. I got 20 million ohms. So if I put my tester between this point and that point and try to raise the voltage, I should be able to. Should be able to here, should be able to there. Yeah, okay, we'll just leave this orange one alone. That's a different filter situation anyway, the orange wire I'm talking about. That's all about the output to cathode resistor bypass. So we're going to hook up a couple of test leads here and see what we can see. Okay, so this is my capacitor tester, and what we hope to do here is put some DC voltage onto the capacitors and see what kind of leakage they have. Electrolytic capacitors always have a bit of leakage. So that's warmed up. Let's just get this hooked up right here. So I want to put the negative onto basically the can of the capacitors, what I'm doing. And I don't want it to touch the chassis at the same time. And we'll go on to any old one of these terminals here. So, not a perfect way to test this. Let's see what the result is. Okay, one result will mean something, another result won't mean nearly as much. That's how I'm anticipating this. So 25 volts, and this is an electrolytic, so we're watching the eye to see if it stays closed. Okay, so it's opening a bit. This is 50 volts in fact. So 50 volts. Now, the people who designed this machine have calibrated it in such a way that the eye should be giving you valid information. I can't be any more certain of what's going on here than trusting the people who developed this machine. So we are in the electrolytic mode. I'm now on 150 volts. Let's see if the eye opens. So the fact that the eye is barely opening, it's really not opening at all. It's what it looks like in the camera, isn't it? So that's a suggestion, according to this instrument, that this capacitor is leaking more than it would normally, because electrolytic capacitors have a bit of a leak in them. Let's try the next one. I'll just move it to another terminal. Now they're all getting energized to some degree here, because they're all kind of connected together through resistors. So again, what exactly am I testing here? Good question. So starting getting 25 volts, just it's kind of a comparative thing. It's about the same. It's about half opening there. What's it doing at 150? Showing the same kind of behavior. It's just open a split, but it really is supposed to open right up like that. So we got a humming radio and we got a filter capacitor that's testing poorly. Anybody surprised about this? The test I'm doing is questionable. The fact that the results are bad may just be a coincidence. So that's 150 right off the bat, and it's doing the same thing too. Barely opening. And I could dig out a nice new filter capacitor, stick it in the tester, and prove what the tester will do, but I don't have to. I know from experience that tester with a good electrolytic capacitor will open right up after the capacitor charges. So we got all indications our capacitor is bad. I mean, the filthy condition of this radio also suggests a bad capacitor. And so I'm not going to bother trying to measure the capacitance because I think it's too leaky, and whatever reading we get, it's going to be bogus anyway. So I won't bother with that. So I don't think there's any doubt we'd be better off disabling the capacitor that's in there. So So I have to think hard about installing a terminal strip in here somehow, somewhere. And transferring all these connections from here to a terminal strip. Now you can see what's going to happen, right? If they are anywhere, if the terminal connection points are anywhere but right here, none of these wires are going to make it there. Or many of the wires will not make it there. He says, quickly assessing how many wires would not make it there. If I put a terminal strip over here, just about every one of these wires can be pulled over to it, except for this red one here. So I mean, it's not as bad as I thought. And then I gotta put 4 capacitors around the terminal strip. Okay, well I think that might be the topic of the next video, because I think I've reached the point here where I know what I need to do. I know what's going on. Well, at least I think I know what's going on. It's a good way to go through life. Okay, we'll see you on the next video.